Good afternoon everyone. Myself is Smriti from ITS College of Pharmacy. Today I am going to teach you potentiometry and its types of titration and its application along with it in pharmaceutical analysis first. Okay. Potentiometric titration is a technique which is similar to the direct titration, and it involves all sort of titration such as precipitation titration, redox titration as well as acid base titration also. And it is very well to achieve endpoint in potentiometric titration because it does not needs any kind of indicator, any sort of indicator for the endpoint. The endpoint simply commences with the potential difference, with the drastic and sudden change in potential difference which comes along with the titration as endpoint comes, as endpoint shows in the titration, which can be measured with easily with the potentiometer. Okay. Potentiometer shows the fluctuation in the potential or voltage difference along the analytical solution in which it is being dipped up. The potentiometer titration is a technique which is similar to the direct titration of a redox reaction or an acid base reaction. It is very useful in determination of acid base reactions as well as redox reactions also. Indicator in this titration in such type of titrations, no indicators is being used or needed. Instead, the potential is being measured across the analyte typically with a potential or voltage drop. The overall electric potential is measured with the E cell, E capital E in capital E with cell means electrode potential of the whole cell. What type of cell? It is a potentiometric cell which involves mainly 4 components which we will study further in our next slides. E cell is equal to E reference minus E indicator minus E reference dot means multiplication into E solution. E solution is the potential drop over the test solution, or test solution is the analytical solution or the solution of the analyte which is to be determined. Okay. The test solution is the analytical solution which is to be determined. Our potentiometer indicates or measures the potential difference between the reference electrode and indicator electrode which are being dipped into the test solution or analytical solution. Analytical solution is the solution of the analyte which is to be determined. E solution, E cell is recorded at the intervals as the titrant is being added up from the burette. तो E cell जो आपका होता है, it is being recorded up, it is being recorded from the potentiometer. Potentiometer is connected to a voltmeter. Voltmeter records up the voltage and it is being recorded from time to time after some intervals as the titrant being added from the burette. The principle which is mainly relies behind the potentiometry is when a metal strip is being dipped up into the solution of its own ion, there are 2 possibilities or tendencies. When a metal strip means electrode, an electrode when a neutral electrode means basically an electrode when it is dipped up in a solution of its own metals, there are 2 possibilities, 2 tendencies which we all very well know. Either there will be a formation of cations or there will be a formation of anions. First tendency or first chance is metal ion may dissolve in the solution as positive ions, leaving behind the electrons on the electrode. First chance that they will form cations, leaving the electrons on the electrode. And the second tendency is that metal ions may take up the electrons from the electrode, leaving and get neutralized themselves, leaving behind the positive charges. Okay, they will become neutral and they will leave the positive charges on the electrode. Thus, a potential difference or a voltage difference is set up between the electrode which is being dipped up and the solution which is under study or for which analytical concentration is to be determined, is to be measured with the potentiometer. So, you got it, there is a potential difference is being created up between the electrode and our analytical solution which is to be determined, which has some analytes which is to be determined, whose concentration is to be determined well with this technique. Potentiometer is an instrument used to determine the potential difference between the reference electrode and the indicator electrode dipped in the solution to be measured or to be analyzed. Potentiometer mainly comprises of different parts, mainly 4 of them are that 2 kinds of electrodes are there, indicator electrodes and reference electrode. Reference electrodes are electrodes which are very stable, it does not show any changes, for which we refer to, and an indicator electrode is an electrode which changes the potential or voltage across the difference in the ionic solution in the analytical solution. As the analyte concentration changes, the potential changes over the indicator electrode, which is being measured by the voltmeter as potential drop or potential sudden potential drop or sudden potential changes. Okay. Measured potential, which is the potential difference, a measured potential which is being measured up from the voltmeter, is used to determine the quantity or concentration of analyte in terms of concentration. जो potential जो हमने voltage drop हमने determine किया है, उसको हम analyte की concentration measure करने के लिए use कर सकते हैं. A potentiometer consists of 2 electrodes. Basically, 2 electrodes are there in a potentiometer. First one is reference electrode and second one is indicator electrode, which is inserted in the test solution. Test solution means analytical solution. Test solution, what do you mean by test? Which is under study, right? Which is under study. So, test solution or analytical solution means the solution whose concentration is to be determined. The test solution or analytical solution whose concentration is to be determined. The voltmeter is attached to the electrode to measure the potential difference between them. A voltmeter is attached in between the reference electrode and indicator electrode to measure the potential difference between the reference electrode, which remains stable, and the indicator electrode, which changes the potential or which shows the potential difference across the changes in concentration of analytical solution or the changes in concentration of analyte. One of the electrode is a reference electrode whose potential is known, is stable, and it is quite insensitive to the analytical solution, okay, which is very stable, which is insensitive to the analytical solution. We will study in deep in our coming slides, in our next slides, next PPTs. The other electrode is the test solution whose potential we need to determine, okay. That potential depends upon the concentration of analyte under study or the concentration of analytes in the solution which are to be determined, whose concentration is to be determined. The concentration can be determined easily by the Nernst equation. Nernst equation determines is an equation which relates between the electrode potential and the concentration of the analytes present inside the test solution. The test electrode or the indicator electrode is usually either a metal immersed in a solution of its own ion or whose concentration you wish to determine or we wish to determine, okay. तो जो हमारा टेस्ट इलेक्ट्रोड होता है या इंडिकेटर इलेक्ट्रोड है, इट इज़ अ सिंपल मेटल electrode, okay, metal and electrode, or it can be a glass electrode also, and it is dipped into the solution of the analyte or analytic concentration whose solution is to be determined. Then comes the working of a potentiometer in the way in which we can determine the potential or voltage across the 2 electrodes, so that we can easily determine the concentration of analytes which is our aim, or which we have to do, which we have to determine. To do this, the electrodes are used in indicator electrode. Indicator electrode are of 2 types, as I told you earlier, glass electrode as well as metal ion electrode, and a reference electrode. Reference electrode generally used they are of 3 types: hydrogen electrode, calomel electrode and silver electrode. The indicator electrode forms the electrochemical half cell, while the other reference electrode forms another electrochemical half cell. The interested ions means the ions which are under study, the ions to be determined, the analytical ions which are to be determined, which are to be known, The interested ions are in the test solution or analytical solution. The ions which are to be determined are inside the analytical solutions, in which both the electrodes are dipped out. The reference electrode forms the other half cell. The reference electrodes forms the other half cell. As I told you earlier, one half cell reaction is being formed up by the indicator electrode and another half cell reaction is being formed up by the reference electrode. For example, here I have quoted you example which is visible on the slide of zinc, that zinc undergoes a reaction by leaving out two electrodes and forming an ion, cation, zinc 2 positive. Okay. Then reduction takes place at the cathode. Okay. तो कैथोड के ऊपर रिडक्शन होगा, ठीक है, एंड एनोड के ऊपर ऑक्सीडेशन होगा. फॉर एग्जाम्पल द सिल्वर इलेक्ट्रोड Ag प्लस leaves out one electron and forms neutral silver Ag. Okay. When the redox reaction takes place, then a potential difference is created upon between the two electrodes, between the test solution and the indicator electrode, which is being measured up by the galvanometer as a potential difference or as a voltage difference. This is the diagram which shows a potentiometer easily. Here you can see one electrode is an indicator electrode and one electrode is a reference electrode. One forms half cell reaction while the other forms the other half cell reaction. We can easily see like that. This is the potentiometer which is attached to this is a potentiometer, okay, which is attached to a voltmeter to determine the voltage drop or potential drop. Okay. Then this is anode and this is cathode. At anode, cations will be formed, right, with the relieving of two electrons, and at cathode neutral silver will be formed with from positive ions. Cations will be changed into neutral silver atoms. Okay. And this is a salt bridge. What is a salt bridge? We will study further in our next slides, in our coming slides. Then what is potentiometric titration curve? Potentiometric titration curve is a titration curve which is being plotted between the volume which is added from the burette and the potential difference. The potential changes along the titration as the titration proceeds. The graph of a potential difference or potential against the volume added from the burette or being added can be drawn at the end point as the end point commences halfway or from the reaction. तो जो भी हमारा potential changes होता है, जैसे जैसे titration proceed करता है, there are potential changes. As the reaction proceeds, there are potential fluctuation, voltage drop or voltage changes across the titration. We can easily plot them between the voltage drop or potential changes against the volume of titrant which is added from the burette. Okay. दोनों के बीच में हम ग्राफ प्लॉट कर सकते हैं. उसको ग्राफ को प्लॉट करने में हमें एक सिग्मॉइड शेप एस शेप ग्राफ मिलेगा, जिससे हमें ये पता चल जाएगा कि हमारा एंड पॉइंट कहाँ पे आ रहा है. वी कैन ईजिली डिटरमाइन वेयर अवर एंड पॉइंट कम्स, राइट, from which we can easily determine E cell. What is E cell? The electrode potential of the potentiometric cell. And E cell depends upon the concentration of the analytical ions or analytical solution which is under study. E cell depends upon the concentration of interested ions with which the indicator electrode is in contact. जो indicator electrode है हमारा, वो हमारे analytical solution के जो आयंस चेंज हो रहे हैं, एनालाइट के जो आयंस चेंज हो रहे हैं, उनका जो कंसंट्रेशन है वो कंसंट्रेशन के जो चेंजेस हैं वो ई सेल के फॉर्म में हमें पता चलेंगे. जो हम ग्राफ में प्लॉट करेंगे उससे हमें एंड पॉइंट पता चलेगा. उससे हम ये पता कर सकते हैं कि हमारा जो एनालिटिकल सोल्यूशन है, what is the concentration of analyte in our analytical solution at a given moment or at a given time of the titration. here a reaction has been shown up, okay, where you can easily see this is the reaction, okay, in which in metal ion changes into a neutral metal with the absorption of electrons. Okay. With this change, the E cell changes, the electrode potential of the cell, of the potentiometric cell changes, which changes the potential, difference across the potentiometric cell, which is being measured up and which shows the total concentration of analytical ion under study. This is the graph. Elaborately I have shown the graph here. How you can plot the graph? This is the volume, this is the, in x axis we will plot the volume, and in y axis this is the E, means electrode potential, which is being measured up from the voltmeter, potential difference which is being measured up from the voltmeter, and this is the volume which is being added up during the titration from burette. As you can easily see, you can very clearly see, we will get a sigmoid shape graph, S-shaped graph we will get. This is a potentiometric titration curve or potentiometric titration graph. As the comments, you can see the graph, when the reaction commences or when you will start the titration, it remains steep. As the reactant reacts with each another, the metal ion concentration changes very slowly. So, the graph remains steep as it approaches the end point. This is the point when it approaches the end point, when it approaches the end point. So, there is a sudden rise, in electrode potential or voltage of the solution under study or the voltage of the analytical solution. Here you can see the sudden voltage rise or electrode potential rise, the graph suddenly goes up, and this is the end point. End point comes here in between the steep rise or the vertical line. This is the horizontal part, this is the vertical part, this is again the horizontal part. Once the end point comes, the analytical solution, analytical concentration, the concentration of analyte in our analytical solution or test solution changes, start changing very slowly again, showing a steep rise in electrode potential. It becomes stable for the changes in potential, for the changes in ions, it becomes stable. This is the end point, after which the graph again becomes steep. So, overall you will get a sigmoid shape or S-shaped graph, and this is the end point where the end point comes. This is the point where the end point comes. Okay. So, this is all about the potentiometric titration curve. The potentiometric titration involves the measurement of E cell with the addition of titrant. ये हमारा E cell है, E cell मतलब electrode potential of the cell which is being measured up, और ये हमारा volume of titrant which is being added up from the burette. What are the types of titration which are being covered in potentiometric titration? What are the types? It is widely applicable to all types of potentiometric titration. First one is precipitation titration. As we all know, water precipitation titration, the volumetric method which are based on the formation of PPT at the end point, formation of slightly soluble precipitate are called precipitation titration. For example, the precipitation of silver chloride with the addition of NaNO3, sodium nitrate, okay, in NaCl in silver nitrate AgNO3. AgNO3 is the precipitating agent which gets precipitated as a salt of silver chloride or AgCl, which shows the commencement of end point. Okay. So, potential difference can be measured in precipitation titration also. It can be easily measured or very well measured not only in precipitation titration, it can be very well easily measured for neutralization or acid base titration and oxidation reduction titration as well. For neutralization reaction or neutralization titration, acid base titration are performed with the standard solution of a strong acid or a strong base with a definite end point with the sudden fluctuation in pH of the solution. Why the pH changes at the end point in neutralization reaction? With the sudden change in pH, it shows the sudden rise or sudden fall in the concentration of H plus ion or acidity or basicity of the solution, which indirectly shows our end point. Okay? So, it can be applicable for those sort of titration also. It can be very well applied to the redox titrations also. A redox titration is a type of titration which is based on redox reaction between the analyte or the analytical solution which is under study, for which concentration is to be determined, and the titrant which is being added up from the burette. The analyte which is taken up in the conical flask and the titrant which is being added up from the burette. Redox titration may involve the use of a redox indicator or a potentiometer. For all the methods, there are suitable indicator for the particular type of reactions also, but since we are studying potentiometry here, so we are showing how potentiometry is applicable for the determination of endpoint in all sorts of titration. What are the advantages of potentiometry, or what are the advantages or application of potentiometry over the other methods, over the other sort of titrations, over the other types of analytical methods? First one, it can be used for all variety of titration, for acid base titrations, for redox titrations, for precipitation titration, as well as for complexometric titration. For precipitation titration, the end point is indicated by the very well formation of a precipitate. The precipitate should be sparingly soluble, okay, or insoluble, and for the complexometry, the end point is indicated by a formation of complex or a chelate, which can be shown easily at the end point, which can be easily determined at the end point. So, for this method, if suppose a indicator is not available, we can go for potentiometry. The potentiometry easily determines the changes over the ionic concentration or the analytical concentration. The concentration of analyte changes, the electrode potential changes, and the electrode potential which is directly related to the concentration of analyte is being determined by our galvanometer. Then second advantage or application is provides more reliable data. Since it involves a total automated system, a machinery, no use of indicator as such, that is why it provides a more reliable data in itself. More reliable data means, for example, indicator sometimes shows indicator error. It does not show the changes of proper color at the end point, at the specific end point. That shows the indicator error, which has to be avoided as in pharmaceutical analysis for determinations to be accurate and precise. So, that is why potentiometry relieves all the types of titration from that sort of indicator error or chemical error. It provides more reliable data because the end point is being easily determined with the help of potential difference or voltage difference across the changes, across the titration with the changes of analytical concentration. As the analytical concentration changes, the voltage also changes, or potential of the potentiometric cell, electrode potential of potentiometric cell also changes, which can be easily seen and calculated also. Then next advantage or application is, it is very useful for turbid and colored solution. One of the problem which comes very far in pharmaceutical analysis is, we can use indicator as well, but at the end point the solution becomes turbid or colored. As I told you, for colored solution, indicator error could be there. Indicator does not shows its color on time, does not shows a proper contrasting bright color as it should have shown, but it also has another problem, that the solution gets turbid or colored. Okay. So, for those kind of solution, if turbidity is there or it shows a deep intense color which has not to be shown in as per the protocol, then you can easily follow potentiometric method, okay, or potentiometric titration, which can easily determine the electrode potential. Then the last advantage or application of potentiometry is that it can be easily automated. It can be easily automated. That means, if you can if you want to use any other machine with that, any other automation with that, if you want this method to become more precise, more accurate, more systematic, then you can do any other automation, okay, which is also possible with this kind of potentiometric titration. So, we can summarize our potentiometric titration as the potentiometric titration, as we all know, is a simple form of titration which comprises of a potentiometric cell. Potentiometric cell mainly comprises of two electrodes, okay, indicator electrode and reference electrode. Indicator electrode, as the name suggests, work as a indicator itself. जैसे हम normal titrations में indicator use करते हैं, indicator shows a change, a drastic change either in form of color or in form of precipitate at the end point. Similar in that way, indicator electrode shows a change, a drastic change in the potential at the end point. Okay. So, that is the purpose of indicator electrode, which is directly related to the changes in analytical concentration or the concentration of the solution in which it is being dipped up. तो indicator electrode का ये purpose है. Reference electrode हमारा बिल्कुल stable होता है, it is quite insensitive to the changes in the analytical concentration of the solution. Reference electrode has the purpose only for the reference. उसको refer करके हमारा indicator electrode अपना potential change करता है जो हमें measure out करना है. Once the E cell is being measured out, उसके हिसाब से उसके साथ once the E cell is being measured out, we can easily calculate our analytical concentration or the concentration of analyte in our test solution or the solution to be determined. Working, we have seen easily the working. One electrode serves as an anode and one electrode serves as a cathode. In this way, the potentiometer works. It is being connected to a voltmeter. Then, if we want to proceed the potentiometric titration without a graph, we can easily proceed without a graph. We can calculate E cell with the help of a Nernst equation by calculating electrode potential of the total cell in itself, or we can plot a graph for easy pictorial depiction of our titration. The graph is to be plotted in between two axes, x axis and y axis. On x axis, we will plot the ml of titrant or the volume of titrant which is being added up, as I told you earlier, and on y axis we have to plot the electrode potential, the changes in electrode potential according to the changes in analytical solution. And this sudden rise in the electrode potential, in between this sudden rise or this vertical line is comes our end point. This point is our end point and this is the neighbor of end point, and this both regions are neighbor of end point, and this is a stable region of titration. This is the stable region of titration. These both horizontal lines are stable region of titration where the electrode potential changes very slowly, or we can say that analytical concentration changes very slowly. Okay. So, this is the way in which we can plot our precipitation curve, precipitation graph. Then these were the types of potentiometric titration, okay, complexometry, precipitation, redox titration, acid base or neutralization titration. As we all know, neutralization titrations are also called as acid base titration. Then this is the advantages or application of potentiometry, as we have already gone through it. It can be very well used for turbid and colored solution. It provides more reliable data. It can be easily automated, and it has wide applicability on all sorts of titration, all types of pharmaceutical analysis which are being held up. For example, neutralization titration, redox, complexometry and precipitation as well.